Voice is okay or? Okay. Today we are going to present how we are using machine learning in the Public Authority for Civil Information in order to automate various types of tasks that are running by passive. State of Kuwait is executing huge infrastructure projects all over the country. Following these projects and coping with them in order to update the GIS data that we have in PASI is a huge task and needs a lot of people in order to work and do this task. In order to update our GIS data, we need to have a source of truth. There is various sources that can be used to be our source to update our data. Using tracking devices, satellite imagery, mobile applications, CDR data, surveying, all this data needs to be consolidated and integrated and processed in order to update our repository and assets. But one main source that is needed in order to update this data is a human. People are our main source of the truth that can feed us with their feedback. One of the main sources to update GIS data, everyone is using it, especially we are in a GIS conference, is satellite imagery. But if we are comparing data and satellite imagery from in the same year for different, just 6 months difference, we can see here in Kuwait how streets are changing. So even if I have people who are dedicated to update the data, in order to update an area, we need more than 3 to 4 months to update an area despite the level of details that we are going to. Once we have finished this, we found that the satellite image for the same area had been changed, which means that we will be ending in a continuous loop. We cannot cope with this change. So we were looking, the other source of data that we have is Kuwait Finder. In quick figures, currently we have more than 650,000 downloads of Kuwait Finder, and we have more than 100,000 unique active users per week who are performing more than 26 million actions and doing more than 4.1 search operations per week, per month. Kuwait Finder, as any GIS-based application, is not using the location services of the device. Kuwait Finder is looking anonymized GPS data with more than 300 million per month. We were thinking, how can we utilize this and how can we use it in order to update our data? The indicators that we can have, people who are using Kuwait Finder are moving in the streets, and we have our street network already available. So if we overlay the GPS points coming from Kuwait Finder and other applications who are using our services or feeding us with the data, we can see that there is a non-stop GPS points, which means that there is a street, despite the level of the street, but there is a street that people are moving from, and we do not have the data updated for it. And this is a very clear example of this. So, as I said, it is a laborious process. So we were thinking, how can we use machine learning? Not for the sake of saying that we are using machine learning, but we are looking how can we use machine learning to automate or at least semi-automate our regular business processes for update our JS data. One, in past we have several use cases that currently we are implementing. I will just to make a quick overview of these use cases. The first one is using machine learning, between brackets, deep learning, in order to extract street networks from the satellite imagery. This is a high-level overview. We are providing an area, just a click for the user. Based on this location, deep learning program is detecting from the satellite image the street existence. This data is fed to the GIS and we have the street network. In order to be more clear, this is a Jupyter notebook. You can see this video. We are using Python here. You can see we are processing data. We are pre-processing the images and processing the data. This is the output from the detection. This took 485 minutes, which is around 8 hours, to segment all state of Kuwait. Updating the street network for all state of Kuwait took 8 hours. Just to make this clear, we are not saying that this is a final product. We are still working on it and we are still enhancing it. So I will not, what you see is just for demo purposes. So these are the streets that are extracted from the machine learning program. Covering the area that we have processed. Look on the details. Here we are extracting the street outlines, not the street center lines, the street outlines. This approach is applicable to be implemented in the various tasks. See how is the parking lot. You can see that why we are saying that it is not final, because there is noise in the data, there is noise in the output, which needs to be post-processed in order to be usable for the final output. So this is what we are working on currently. And by the way, this is done by BAS. There is no company that is working on this. And if you were in the plenary yesterday, you see Mansour Ra'ad was mentioning that we are working on this. So we are collaborating and working even with ISRI and we're working with Microsoft to join forces in order to be able to do this. The work that we are executing now will be shared from BASI to all government agencies free of charge. You see شو اسمها بالعربي بالانجليزي the flower, the details that is around the street. Another use case, which actually was our trigger of exploring using the machine learning. As you know, in 2017, we have launched the live traffic map for Kuwait. Now, we were relying in the same way like other service providers, Google, Waze, here, how they are creating the traffic map, which is using the anonymized GPS data, apply real-time analytics, and produce the traffic map. Now, we cannot claim that Wayfinder or other applications that are providing us with the data, with the raw data, is covering all Kuwait at the same time. So the concept, maybe some of you last year saw this, we have the GPS data, we are accumulating it, updating the street network based on the traffic likelihood and probability, and generating the colorful traffic map. I will not go in detail on this, just now this data is coming. As we do not have all the streets of Kuwait covered by Kuwait Finder users and other application users at the same time, we will be facing street segments that we do not have data on. So what shall we do? Currently, what we are doing, these missing data are colored as green, which means that it has stream traffic, and this is wrong. But this is how applied in many applications. But we were thinking, how can we, instead of doing just a default color, green for this area, how can we use machine learning to predict the status and the likelihood of the traffic for this segment? Traffic calculation or traffic likelihood, it is a mathematical formula that needs a lot of tuning in order to be correct. So every time we are getting additional data or more data, we need to tune it manually. And this needs a lot of explicitly work. We need to be very explicit on programming for this. So the decision was coming. Okay, we have more than 500 days of GPS logs. We have the street networks. We have the time. So how can we learn from this data in order to be able to predict the missing data that we have? We have various features. We have the unique identifiers for the GPS points, timestamps, likelihood, average velocity, speed differences, and the geometry. And we need to apply geographically weighted likelihood. We cannot say, take the data and predict that this is the traffic condition all over the Kuwait in this hour. Because currently, at 9 o'clock in capital, in Al-Azmeh, the traffic condition is totally different than the traffic condition in Al-Aqil. So we need to apply a geographically weighted machine learning. And in order to be able to validate the output of this machine learning algorithm, we need to be able to visualize it. And this is our difference as GIS users from the people or the practitioners from machine learning. Usually machine learning output, it is a graph showing the loss and the accuracy of the model, and they will say that the model is correct and the model is not correct. But we at GIS, we have the additional capability that the output of the machine learning algorithm can be visualized in GIS. So directly you can see the output is correct or the output is wrong. And I will give you now, I will show you an example from this. This is just predicting the traffic likelihood on GPS points. This is a video showing traffic prediction on an hourly basis for state of Kuwait. So we can select a day, an hour, and get the prediction or the traffic prediction for this extent. These are the normal color streets. It does not mean anything. So we are doing now simulation. So simulation for Sunday for the whole 24 hours to see what is the output. 0, 12 at night, and we are moving hour by hour, and you can see it on the map. 6 in the morning, 7, 8, 9. You can see the prediction, and by yourself, because you are visualizing it, you can say that this is correct or wrong. أربعة، خمسة. طبعا الاوتبوت هذا sorry. This output we just used 1 month data. Okay, just to do the presentation, but actually the output is totally different. And you can see the time, yeah, number of features, number of street segments, and this extent is 2,000 features. Segments does not mean that we have 2,000 streets in this area. Street segments, geometry, and predicting this data, it is taking 0.3 or 0.4 seconds to be able to serve it to the user. How this will be applied? Currently, we find the users are panning, zooming in order to visualize the extent or visualize the map. This is in the back end is doing a request to our application server. Based on the extent, we are hitting 2 tracks. One is to provide the user with the current live traffic map that happens based on the data that we receive, and all missing street segments that do not have data will be predicted. Both of them are combined together and sent back to the user. Now, this is to-do list that we are working on it, doing hyperparameters, cross-validation, fishnet toolbox for the geographically weighted prediction, street geometry, considering the direction of the street geometry, and trying to apply other different algorithms. This is our team in PASI, which we are proud of, and actually this is a subset of the team of PASI in GIS. Our team is much bigger than this, working in different disciplines and domains. Thank you. Questions? خالد. الأسئلة هلا خالد ولا الآن؟